So after emulating the Sinclair computers, there's one last computer I want to emulate, which is the Jupiter Ace. Although it wasn't made by Sinclair, it was made by a couple of people that had left Sinclair, who had worked on the ZX81 and the Sinclair Spectrum. So if I start up the emulation, there's a few differences and there's a few things which are similar. So it's a white on black display, and it runs a thing called a programming language called Forth. So if I type a command called vlist, and that displays a vocabulary which is in the Forth language. So the Sinclair computers ran BASIC, and the Jupiter Ace ran this Forth language. And I don't really know much about Forth, and I've only know what I've learned just after having put this emulation together. But you can type, so it has this vocabulary, like I say, which has I've just listed what's the internal words, and in Forth you produce your own definitions of new things to go in the vocabulary. So you would do that by typing a colon, and if I type a name char set to add this to the definitions, and you type in what definition is. So 256 to 0. So it works by putting values onto a stack. So I've just put 256 and 0 onto the stack, and then running other commands which are more kind of programming language type commands, which is, so I've got a do loop. So I've started a do loop, and if I type I and then space, so I is like the iterator in the loop, and if you type emit, it outputs character value for I, and then I finish it off by ending the loop and put in a semicolon. So now that's, if I do another vlist, the char set word should now be at the top of the vlist, and there it is there. And so if I now type the word char set and return, it then runs that command and it outputs the character set of the actual machine. So this is where we get another difference and similarity as well. So it's similar to the ZX81 in that it's a character-based system. So there's no high-res graphics as such, although you can redefine the characters like you can on the Spectrum to be different characters on this particular computer. But you can't plot high-res graphics like you can on the Spectrum, but you can plot the low-res graphics like you can on the ZX81 with the plot and unplot command. So it's similar like that. So, and the reason for that is it uses DMA to update the display like you do on the Spectrum, but it only updates using the character set that's defined in the memory like you do on the ZX81. So it's kind of a halfway house between the two computers. So the actual emulation in source code is very similar to the other Sinclair computers. The Z80 is emulated exactly the same way. So I've been through that in a few of the other videos, so I won't go through that in this video. If you want to know about the Z80 emulation, then take a look at some of the Sinclair videos that I've made. But there's the main application, the main routine here, the entry point, where it creates the display. It initializes in exactly the same way as the other emulators. So if you look at the other emulators, this is all done in a very similar way. There's a difference here in that there's several 1K blocks of memory within the Jupiter Ace. So one is to define a character set, I think one's to define what's on the display, and one's like a work area where the Forth does its working it out. And each of those is actually mirrored in a different location in memory as well. So that's where I've got these three mirror memory parts here. And then the ROM is loaded up as well in the bottom part of memory, and just like the other Sinclair computers. So after that, there's only one callback function for a port. So it's got a keyboard port like the other Sinclair computers, and then there's the clock callback for every clock cycle, so I can decide what to do on each clock cycle. Then it just goes in to execute the emulation there, and on the exit it just cleans up by freeing up memory and removing the display resources, the window resources. So the creation of the actual virtual machine itself is very much the same. And this keyboard callback is on the same port as, I think it's on the same port as the Sinclair computers, so it's similar in that way. At the top of here, this is all cassette handling stuff, which is just from the emulation which I copied from. I need to update this to be the Jupiter Ace cassette saving and loading stuff. But at the bottom of there, so this is exactly the same source code as I used for the Sinclair computers. So the keyboard actually handling, reading keys and deciding what's happening on those keys is exactly the same in hardware. In software it's done slightly different, so there are some slight differences there. But if you look at the other videos, you'll see that same code in there. This is the cassette saving, so I've just commented that out until I've rewritten that. But then there's just a little bit of code at the very bottom here where it does a clock callback, so I decide what to do. This top part is the same as you get in the other Sinclair computers, where it reads keys and queues them up for processing. And also I've implemented loading a snapshot as well, like I've got on the other Sinclair computers. And then the only other thing is updating the display. And although it's kind of a hybrid between the two, so it uses DMA memory access. So here you see it reading DMA memory to actually read what characters need to go on the display, and then it reads the character definition. So it does that very similarly to the ZX Spectrum, and it just then plots that stuff exactly the same like it would on the other computers as well. The algorithm is slightly different, but if you look at the other two, you've still got like your loops to do the actual updates, the memory reading, and then the graphic plotting. So the actual routine is very similar to both of the other display updates. But apart from that, that's the emulation. So it's a very simple computer to actually emulate.